Hello, and welcome. Tonight, we're going to drift through the universe together. There are no tests, no important details to memorize, and nowhere you need to be. Just relax, get comfortable, and let your mind wander among the stars. As you listen, imagine yourself floating gently through space, moving slowly through the vast cosmic ocean. The universe is unimaginably large, incredibly old, and filled with wonders beyond counting. And yet every atom in your body is connected to this grand story. Let's begin. The universe is older than almost anything we can imagine. Scientists estimate that the universe is about 13.8 billion years old. To appreciate how long that is, imagine compressing the entire history of the universe into a single calendar year. In this cosmic calendar, the Big Bang happens just after midnight on January 1st. The Milky Way forms in March. The Sun and Earth appear in early September. Dinosaurs arrive on Christmas Day. They disappear on December 30th. And all of recorded human history occupies only the last few seconds before midnight on New Year's Eve. Everything humans have ever built, written, discovered, or remembered fits into a tiny fraction of cosmic time. The universe was already ancient long before Earth existed. The universe began extremely small. The observable universe today stretches across billions of light years, yet scientists believe it once existed in an incredibly hot, dense state smaller than an atom. Then, in a tiny fraction of a second, it expanded dramatically. This event is known as cosmic inflation. Space itself expanded faster than the speed of light, not objects moving through space, space itself growing larger. The universe has continued expanding ever since. Right now, galaxies are moving away from one another because the fabric of space is still stretching. The cosmos is not static. It is constantly changing. Light travels fast, yet space is vast light, moves at roughly 186,000 miles per second, or about 300,000 kilometers per second. A beam of light could circle Earth more than 7 times in a single second. And yet, even at this incredible speed, traveling across the universe takes a very long time. Light from the moon reaches Earth in about 1.3 seconds. Light from the sun takes roughly 8 minutes. The nearest star beyond the sun is over 4 years away at light speed. The Milky Way galaxy is about 100,000 light-years wide. Simply crossing our galaxy would take longer than all of recorded human history by an enormous margin. Every star you see is a time machine. When you look at the night sky, you are seeing the past, because light takes time to travel. The moon appears as it was 1.3 seconds ago. The sun appears as it was 8 minutes ago. Many stars appear as they were decades, centuries, or even thousands of years ago. Some galaxies visible through powerful telescopes appear as they were billions of years in the past. Astronomy is unique among sciences. The farther we look, the further back in time we see. The universe allows us to witness its own history. The Milky Way contains hundreds of billions of stars. Our home galaxy is called the Milky Way. It is a vast spiral galaxy filled with stars, planets, gas, dust, and mysterious dark matter. Scientists estimate it contains between 100 and 400 billion stars. That's so many stars that counting one every second would take thousands of years. Our sun is just one ordinary star among these hundreds of billions. And our solar system lies in a quiet outer region of the galaxy, far from the crowded center, moving peacefully through space. The sun is surprisingly ordinary. The sun feels special because it gives us warmth and life, but in cosmic terms, it is fairly average. There are stars much larger, stars much hotter, stars much brighter. Some stars are hundreds of times wider than the sun. Others burn tens of thousands of times brighter. Yet average stars may be exactly what life needs. The sun's stability has allowed life on Earth to flourish for billions of years. Sometimes, ordinary things are extraordinary in their own way. There may be more planets than stars. For centuries, humans wondered whether planets existed around other stars. Today we know they do. Thousands of exoplanets have already been discovered. Many solar systems appear completely different from our own. Some planets orbit 2 stars. Some are larger than Jupiter. Some may be covered entirely by oceans. Scientists now suspect there could be trillions of planets in the Milky Way alone. Perhaps more planets than stars, each one a potential world with its own story. The largest planet in our solar system, Jupiter, is enormous. More than 1,300 Earths could fit inside it. Its magnetic field is powerful. Its storms are immense. The Great Red Spot is a giant storm that has raged for centuries. The storm is so large that Earth could fit inside it. Jupiter acts as a kind of cosmic guardian. Its powerful gravity influences countless objects throughout the solar system. Saturn could float. In water, Saturn is famous for its rings. These rings are made mostly of ice particles. Some are tiny, others are as large as mountains. One surprising fact about Saturn is its density. If you could somehow find an ocean large enough, Saturn would float. It is less dense than water. Of course, such an ocean could never exist, but it remains one of the most charming facts in astronomy. A day on Venus is longer than a year. Venus rotates very slowly. One full rotation takes about 243 Earth days, yet Venus completes an orbit around the Sun in about 225 Earth days. This means a day on Venus lasts longer than a Venusian year. Imagine celebrating your birthday before the sun has risen once. The universe is filled with strange and beautiful exceptions. Neutron stars are astonishingly dense. When massive stars die, they can leave behind neutron stars. These objects are incredibly dense. A teaspoon of neutron star material would weigh billions of tons on Earth. Inside, matter is compressed to extraordinary extremes. Yet neutron stars are only about 20 kilometers across. Tiny on cosmic scales, but among the densest objects known. Black holes bend reality. Black holes are regions where gravity becomes so powerful that nothing can escape once it crosses a boundary called the event horizon. Not even light. Black holes are not cosmic vacuum cleaners. They don't roam the universe, swallowing everything nearby. If our sun were magically replaced by a black hole of equal mass, Earth would continue orbiting normally. The difference would be the absence of sunlight. Black holes reveal just how strange reality can become. Supermassive black holes live in galactic centers. At the center of most large galaxies sits a supermassive black hole. Our Milky Way contains one called Sagittarius, a star. It holds millions of times the mass of the Sun. Some supermassive black holes contain billions of solar masses. Despite their immense size, they occupy surprisingly small regions compared to their host galaxies. These hidden giants help shape the evolution of galaxies across cosmic time. The quiet darkness. Between stars, space is often described as empty. Yet even the emptiest regions contain particles, radiation, and magnetic fields. Still, compared with Earth's atmosphere, interstellar space is astonishingly sparse. The distance between stars is mostly vast emptiness. This immense openness gives the universe its sense of grandeur and mystery. There are more stars than grains of sand. Scientists estimate that the observable universe may contain more stars than all the grains of sand on every beach on Earth. Think about that for a moment. Every shoreline, every desert dune, every grain. And still, the stars may outnumber them all. The scale of the cosmos stretches far beyond ordinary intuition. Dark matter remains. Invisible. Most of the matter in the universe appears to be invisible. Astronomers call it dark matter. It does not emit light. It does not reflect light. Yet its gravity influences galaxies. Without dark matter, many galaxies would not behave the way we observe. Scientists still do not know exactly what dark matter is. It remains one of the great mysteries of modern science. Dark energy may dominate the cosmos. Even more mysterious is dark energy. Observations suggest the expansion of the universe is accelerating. Something appears to be pushing galaxies apart faster over time. Scientists call this effect dark energy. Together, dark matter and dark energy make up most of the universe. Everything familiar, stars, planets, people, oceans, mountains, represents only a small fraction of cosmic reality. The atoms in your body were forged in stars. The hydrogen in your body originated near the beginning of the universe. Many heavier elements were created inside stars: carbon, oxygen, iron, calcium. When stars died, they scattered these elements into space. Later generations of stars and planets formed from that material, including Earth, including you. Every breath you take contains atoms with ancient cosmic histories. You are connected to stars that lived and died long before our sun was born. The universe is still full of mysteries. Despite centuries of discovery, we do not know everything. We still do not fully understand dark matter, or dark energy, or what happened before cosmic inflation, or whether life exists elsewhere. Every answer seems to reveal new questions. And perhaps that is one of the most beautiful things about science. The universe remains larger than our understanding, inviting curiosity, inviting wonder. A final thought before sleep. As we come to the end of our journey, imagine the Earth floating quietly in the darkness, a small blue world orbiting an ordinary star. In a galaxy among billions of some stars live for trillions of years. Not all stars age at the same rate. Large stars burn through their fuel quickly. Some survive only a few million years before ending their lives. Smaller stars are much more patient. Red dwarf stars consume their fuel so slowly that many could shine for trillions of years. This is far longer than the current age of the universe. In fact, the universe is not yet old enough for a single red dwarf star to have naturally reached the end of its life. Every red dwarf ever formed is still shining somewhere in the cosmos. The longest-lived stars are still in the earliest chapters of their stories. The night sky changes very slowly. The constellations appear permanent. People thousands of years ago looked up and saw many of the same patterns we recognize today. But stars are constantly moving. Over vast periods of time, familiar constellations gradually change shape. If you could travel hundreds of thousands of years into the future, Orion would look different. The Big Dipper would look different. The sky itself would slowly rearrange. The universe is dynamic, even when it appears still. There are planets without stars. Most planets orbit stars, but some do not. These are called rogue planets. They drift through interstellar space without a parent star. Some may have been ejected from their solar systems long ago. Others may have formed independently. Imagine standing on a world with no sunrise, no sunset, no bright star crossing the sky, only darkness and distant points of light. Such lonely worlds may be surprisingly common. The largest known structures are almost impossible to imagine. Galaxies gather into clusters. Clusters gather into superclusters. These form vast networks called the cosmic web. The cosmic web stretches across hundreds of millions of light years. Enormous filaments of galaxies connect like strands of a giant cosmic spider web. Between these filaments lie gigantic voids, regions of space where relatively few galaxies exist. If the Milky Way were the size of a grain of sand, these structures would still be unimaginably large. Space is not completely silent. People often say space is silent, and for human ears that is true. Sound requires a medium through which to travel, yet space contains vibrations, magnetic fields, charged particles, waves moving through hot gases. Scientists can convert these signals into sounds we can hear. The universe contains rhythms and patterns hidden within its darkness. The moon is slowly moving away. The moon drifts away from Earth by about the rate that fingernails grow, just a few centimeters each year. This tiny motion adds up over immense periods of time. Hundreds of millions of years ago, the moon appeared much larger in the sky. Earth's days were shorter. The relationship between Earth and moon continues evolving even now. The night sky is not frozen. It is slowly changing. Earth has traveled farther than you think right now. Earth is orbiting the Sun at roughly 67,000 miles per hour. The Sun is orbiting the center of the Milky Way. The Milky Way itself is moving through space. Even while sitting completely still, you are traveling at extraordinary speeds. During the time it takes to fall asleep, Earth moves thousands of miles through the cosmos. Yet everything feels calm and steady. Motion, on a cosmic scale, often goes unnoticed. The center of the Milky Way is crowded. Our solar system resides in a relatively quiet neighborhood. The center of the galaxy is very different. Stars are packed much more closely together. The night sky there would be dazzling. Bright stars could appear everywhere. Some might shine brightly enough to cast shadows. It would be a very different experience from the dark skies we know on Earth. Some worlds have diamond rain. Deep inside certain giant planets, pressures become immense. Scientists believe carbon may be compressed into diamonds. On planets such as Neptune and Uranus, diamond rain may fall through the deep interior. Imagine sparkling diamonds descending through layers of exotic atmosphere. The universe often seems more creative than fiction. Nebulae are stellar nurseries. Nebulae are enormous clouds of gas and dust. Within these clouds, gravity slowly gathers material together. Over time, stars begin to form. Some of the most beautiful images ever captured by telescopes show these stellar nurseries. Brilliant colors reveal regions where new suns are being born. Every star, including our sun, likely began its life inside a nebula. The sun is about halfway through its life. Our sun formed around 4.6 billion years ago. Scientists estimate it has roughly 5 billion years remaining before major changes begin. In cosmic terms, the sun is middle-aged. It has spent billions of years providing light and warmth, and it will continue doing so for billions more. The sun's story is far from over. One day, the sun will become a red giant. Eventually, the sun will exhaust much of its hydrogen fuel. It will expand dramatically. Its outer layers will grow larger and larger. Mercury will likely disappear. Venus may disappear as well. Earth's future remains uncertain. After shedding its outer layers, the sun will leave behind a dense remnant called a white dwarf. Its final chapter will be quiet compared to its bright youth. White dwarfs slowly fade. A white dwarf no longer generates energy through nuclear fusion. Instead, it gradually cools. Over unimaginable periods of time, it radiates away its remaining heat. The process takes trillions upon trillions of years. The universe is not yet old enough for a white dwarf to have completely cooled. The future contains forms of darkness no one has ever witnessed. The universe may have no center. A common question is where the center of the universe is. According to modern cosmology, the observable universe does not appear to have a central location. Expansion occurs everywhere. Every galaxy sees other distant galaxies moving away. Like raisins in rising bread dough, everything grows farther apart as space expands. No single raisin occupies the center. Gravity shapes everything. Gravity is the architect of the cosmos. It gathers gas into stars, stars into galaxies, galaxies into clusters. Without gravity, the universe would look completely different. Planets would never form, stars would never ignite. Life as we know it would never emerge. Gravity quietly shapes the grand structure of existence. Some galaxies are cannibals. Galaxies frequently interact. Sometimes they pass near one another. Sometimes they collide. Large galaxies often absorb smaller companions. The Milky Way has consumed many smaller galaxies throughout its history. Evidence of these ancient mergers still exists. Long streams of stars stretch across the galaxy, marking where smaller systems were pulled apart. The Milky Way and Andromeda are heading toward each other. Our nearest large galactic neighbor is the Andromeda Galaxy. It is approaching us, not because space is shrinking, but because gravity is pulling our galaxies together. The collision will not happen for billions of years. When it does, individual stars are unlikely to crash into one another. Instead, the galaxies will slowly merge into a new, larger system. A cosmic dance lasting millions of years. Cosmic sunsets are redder as light travels through Earth's atmosphere. Shorter wavelengths scatter more easily. This is why sunsets appear red and orange. The same physics operates throughout the universe. Simple natural laws create some of the most beautiful sights imaginable. From colorful nebulae to glowing sunsets, complexity often emerges from elegant simplicity. There may be oceans beneath ice. Several moons in our solar system may hide vast oceans beneath frozen surfaces, Europa, Enceladus, and others. Beneath thick ice shells, liquid water may exist in darkness. These hidden oceans contain more water than all of Earth's oceans combined. Some scientists consider them among the most promising places to search for extraterrestrial life. Every photon has been traveling for ages. Some of the light-entering telescopes tonight began its journey before humans existed, before civilizations, before mammals. Some photons have traveled for billions of years, crossing unimaginable distances, only to end their journey in a telescope mirror or a human eye. The universe constantly delivers messages from the distant past. The cosmos is incredibly patient. Stars take millions of years to form. Galaxies evolve over billions. The universe measures time on scales almost impossible to comprehend. Compared with cosmic history, human lives are brief. Yet that brevity makes them precious. For a short time, the universe becomes aware of itself through conscious beings. For a short time, atoms assembled into people can look upward and wonder. And perhaps that is one of the most remarkable facts of all.